bunnies. Today we're going to talk about Newton's second law of motion. Newton's second law of motion. So yesterday when we were defining our laws, we wrote down that Newton's second law of motion, there's a formula attached to it. So the formula is that acceleration is equal to F net divided by mass, where acceleration is in meters per second squared, F net is in newtons, and mass is in kilograms. That formula is on your formula sheet. In words, Newton's second law states that an unbalanced or net force will cause a mass to accelerate in the direction of the net force. When we look at this, what this means, if we look at this formula, this means I'm going to introduce a symbol here that we haven't used before. That symbol is like a little fish symbol, and this means is proportional to. It's the symbol that we use if we need to talk about the relationship between variables in a formula when we don't know the value of all the variables. We can use proportionate, like that is proportionate to. So we're going to be working with this in a few minutes to do some slightly more difficult type of questions. So what we recognize from that formula is that the acceleration is directly proportional to F net. So that's what that means. So this means acceleration is directly proportional to F net. Another way of thinking about that, just make a little bit more space here, is that a change to F net results in the same change to acceleration. I think that's more space than I wanted. So A is directly proportional to F net. A change to F net results in the same change to acceleration. Let's see if I can move this a little bit. I just want to be able to get everything up. Move this up here. Okay, there we go. Just got started. I didn't want to undo the video and have to do the video. Okay, so we have that. Then we also have that acceleration is inversely proportional, or proportional to 1 over m, which means A is inversely proportional to m. So in other words, a change to m results in the opposite change to A. Another way that we can look at that, this is starting to get a little bit squished here, but if we were to graph these, so again, one little bit of adjustment here and bring stuff down. So if I move over here now, what we're going to do is we're going to graph, or here, if we were to graph acceleration versus F net, that's a linear relationship. That mathematical relationship is linear. As F net increases, acceleration increases. If we were to graph acceleration versus mass, then that has an inverse relationship. As the mass gets larger, the acceleration gets quite a bit smaller because you're dividing at each step. So to do some straightforward examples first, before we get to some examples we're using as proportionality. A net force of 18 newtons north acts on a 15 kilogram object. What is the acceleration of the object? So we don't have much. As formulas go, this one's pretty easy to use. F net equals 18.0 newtons. Everything's north. I'm going to make north positive and south negative. We have a mass of 15.0 kilograms, and we want an acceleration. We want to find acceleration. So acceleration equals F net divided by mass. F net is 18.0 newtons. Mass is 15.0 kilograms. So our acceleration is 1.20 meters per second squared, and it's in the same direction as the acceleration, so then that's north. Of course, we can make the questions more complicated by having to do a kinematics calculation first, because now that we've learned kinematics for first unit, those formulas are fair game in all of the subsequent units after. So here we have a 64 kilogram object accelerates uniformly from rest to a velocity of 16 meters per second east, and the object's displacement during that time is 50 meters. What is its net force during this acceleration? So we'll list the information we have. We have our mass is 64 kilograms. We want to know F net. But in order to know F net, we need acceleration, right? So we have F net equals mass times acceleration. And right now all we have is mass, which is 64 kilograms. We don't have a value for acceleration. We're missing our acceleration. So that means we need to find acceleration first. And if we look at the rest of the information that we have here, we have from rest, so VI is 0, to an acceleration of 16 meters per second east. Sorry, I added a 0 there, that isn't a 0, 16 meters per second east. Everything is east, so we'll make east positive and west negative. We have the displacement during the acceleration is 50 meters. And so from that information, we want to find acceleration. So we have everything but time, which means we're going to use Vf squared equals Vi squared plus 2ab. So, acceleration is Vf squared minus Vi squared over 2 times v. So Vf is 16 meters per second squared minus 0 meters per second squared divided by 2 times 50 meters. Now we actually don't need to include the 0 meters per second squared. We can leave that right out, and we need to make sure, if we're going to do this in one step, that we put a larger set of brackets around the 2 times 50 so that it divides by 100, not divides by 2, multiplies by 50. So we have 16 squared divided by bracket 2 times 50 bracket. So that gives me 2.56 meters per second squared. Okay, and that's east. So then that value there, we're going to plug up into this equation here, where we're waiting for our acceleration. So we get 2.56 meters per second squared times 64. So that gives us a net force of 163.84. Or if I'm going to attempt to keep with sig dates, so 164 newtons is fine. But you give a 1.6 times 10 to the 2 newtons east. Okay, our next set of questions that we're going to look at is looking at proportionalities, or like a proportional situation. So we're looking at a situation where we have we're given some values, but not all the values, and we're just going to use the fact that acceleration is directly proportional to F net and inversely proportional to m to calculate some new values. So we'll try this here. This can typically be a little bit challenging, but it is possible to make up numbers on here, like to make up numbers to solve this, as opposed to kind of doing it this way. the way that I'm going to show you. We'll see how this goes. Okay, so what we have here, so we have the acceleration of an object is 24 meters per second squared. That's all we have. What its acceleration is. So we know acceleration equals 24 meters per second squared. We want to know what happens to the acceleration in 3 different situations. So we're always going to be going back to that initial acceleration for each subsequent question. So what we want to remember is that acceleration is directly proportional to F net. Right, so that graph was linear, and acceleration is inversely proportional to mass. So that graph is an inverse graph. So whatever change you make to F net, you make the exact same change to acceleration. Whatever change you make to mass, you make the opposite change to acceleration. So we have for part A, the net force increases by a factor of 4. Okay, so increases by a factor of 4. What that means is that F net is going to become 4 times F net. So what we have is that if acceleration is directly proportional to F net, whatever that old F net was, that gave us an acceleration of 24 meters per second squared. Our new acceleration is going to be directly proportional to the F net as well as the change that we made to F net. So it's directly proportional to 4 times F net. So we multiplied F net by 4. So what that means is to find our new acceleration needs to be 4 times our old acceleration. So that's going to give us 4 times 24.0 meters per second squared. So that would be 96 meters per second squared. So our original acceleration, which was directly proportional to just F net, was 24 meters per second squared. Our new acceleration is directly proportional to 4 times F net. So whatever acceleration we got when it was proportional to F net, we have to multiply that by 4 to get it, to see what our new acceleration is. A way of doing this, like I'm just going to kind of show this and then I'm going to erase it in here. Maybe I can see if you can here. You don't like using the proportionalities. And what you can do is make up numbers. So let's see. So we've got, let's just say we want to have F net. Let's say F net equals 48 newtons and our mass equals 2 kilograms. That gives us an acceleration of 24 meters per second squared. So what I'm going to do now is what I've done is I've taken my F net and I'm multiplying it by 4. So 4 times F net is 192. So now my acceleration is 192 newtons divided by 2 kilograms, which gives me 96 meters per second squared. So I do it that way. The limitation to that is when we get to slightly more complicated formulas that are different than acceleration as F net over mass, that doesn't work anymore. But in a pinch, it'll work. These, by the way, these questions we're doing here, these are all blue level standard of excellence questions. It's these are standard of excellence questions that are in the top level of the verbs that we talk about. Okay, so they're all blue. Okay. So let's try one with mass. The mass decreases by a factor of 3. So what we have happening here, so if it decreases by a factor of 3, that doesn't mean mass minus 3. That means it's going to 1/3 of its original value. So mass becomes mass over 3. Mass divided by 3. So if we take a look at our relationship between acceleration and mass, acceleration is inversely proportional to mass. And so with mass being equal to just m, that gave us an acceleration of 24 meters per second squared. This one's a little bit more challenging to do. But what we have happening here is that we're going to look at our new acceleration. So our new acceleration needs to be, it's going to be inversely proportional to 1 over mass over 3, right? Because now it's 1 over mass, but whatever change we make to mass, we have to account for that. So we're dividing our mass by 3. What that means in the end is we're going to multiply our acceleration by 3. So we divided mass by 3, we're going to multiply our acceleration by 3. But I'm also going to show you where that comes from in here. So this is 1 divided by mass over 3, which is 1 times 3 over mass. So that gives you 3 times 1 over mass. 3 times 1 over mass. Write the 3 again. 3 times 1 over mass. So our new acceleration is going to be equal to 3 times our old acceleration, which we got from 1 over mass. So 3 times 24.0 meters per second squared, which will be 72.0 meters per second squared. I'm going to slip in. Yeah, here, I'm going to go back up here. Now, you could also do that with our numbers that we made up. We'd have 48. So we have to take, if we're looking at those numbers up there, we'd have to take our mass and divide it by 3. So we have to do 48 divided by bracket 2 divided by 3 bracket, and that gives us 72. So that works out. So now what we're going to do is we're going to try and do a net force change at the same time as a mass change. And we're going to go the opposite way here. So you can do this in 2 separate steps, like one like part A, one like part B, or you can do it all together. We'll see how this pans out, where I end up doing it. So we have net force decreases by a factor of 2. So we have F net becomes F net over 2, dividing F net by 2. Mass increases by a factor of 4. So mass becomes 4 times mass. So really what you're trying to do here, if you're going to put in more than one change in, you're trying to come up with the factor that you're going to multiply the old acceleration by. You're trying to figure out what you're going to multiply the old acceleration by to get the new acceleration given these changes. So our old acceleration, or our original acceleration, is 24 meters per second squared. So if we think about this, I think I'm going to end up doing these separately, but I can show you them together as well. Our acceleration is directly proportional to F net, and it's inversely proportional to mass. So our new acceleration here has to be directly proportional to F net over 2. Because we're dividing by 2. So for this one, we're going to divide acceleration by 2. When we take a look at 4 times mass, new acceleration has to be inversely proportional to 1 over 4 times mass. So again, I'm taking a look as I multiplied mass by 4. So I'm going to divide F net by 4. I can get that by just splitting this up. I get 1 over 4 times 1 over mass. And there's my multiplication factor. But there's my multiplication factor. This really can also be written as 1 over 2 times F net. And there's my multiplication factor there as well. So the change in F net tells me I have to divide acceleration by 2. The change in M says I have to divide acceleration by 4. So to divide by 2 divided by 4 means I'm dividing by 8. So if I put it together in here, just to think about this, well actually let's just go divide by 2. So I have acceleration equals new acceleration equals equals fold acceleration divided by 2. So that's going to give me 24.0 meters per second squared over 2, which is 12.0 meters per second squared. Then what I need to do is now I need to take a look at my new acceleration here is going to be my 12 meters per second squared divided by 4, which gives me 3.0 meters per second squared. So then that would be my final answer for this one. These types of questions will come with time and with practice. So if it feels a little bit odd, just do a little bit of practicing with it and do that making up of numbers. And again, in this one, if we made up the numbers, we're going to divide our F-net by 2. So our F-net are 48 newtons becomes 24. Okay? And then our mass, we're going to multiply by 4. So our mass becomes 8. So then we're doing 24 divided by 8 to get our acceleration, which is 3 meters per second squared. All right. The last little bit we're going to talk about in here that relates to this was just a nice short little lesson. I'm going to give you lots of time to do some practice questions. The next thing we just want to talk about is weight versus mass. And then we're going to look at a formula that relates weight and mass. Okay? So mass is signified with the letter M, and it's measured in kilograms. In kilograms. It is a scalar value. And for physics purposes, okay, because I recognize that when we get on a scale, a weight scale, and get our mass, that mass can fluctuate. When we're talking about mass in physics, mass is a constant value. Okay? A constant value that measures the amount of matter in an object. It does not vary. It's a constant value. Okay? That means it doesn't vary. Vary with location. Doesn't vary with location. Weight, on the other hand, is measured in newtons, which means it's a force. So weight is a force. In fact, weight is another word for the force due to gravity acting on an object. So it is a vector. And it is a measure of the force of gravity acting on an object. It varies depending on location. The formula that relates weight and mass is G, acceleration due to gravity, which is measured in meters per second squared, is equal to Fg over M. Newtons over kilograms. Now the other thing is that G, near Earth's surface, it's actually on your formula sheet this way, is A with a little subscript G and absolute value brackets that we'll talk about when I get back. The absolute value brackets do not matter. Just means absolute values will measure how far something is away from 0. And so it's 9.81 meters per second squared near Earth. That's on your formula sheet as well. So this formula and being something we need to know are both on your formula sheet. Okay, so we want to determine the weight of a 16.7 kilogram object near Earth's surface. So near Earth's surface, our acceleration due to gravity is 9.81 meters per second squared. Our mass is 16.7 kilograms. And we want Fg. Fg equals mg. And that's just this formula we arranged for Fm, is multiplying both sides by m to get my Fg by itself. So that's 16.7 kilograms times 9.81 meters per second squared, which will give me 164 or 163.827 or 164 newtons. And weight always acts down, Fg always acts down, but it doesn't matter if we put that on there. It's sort of optional. If we want to find the acceleration due to gravity at an unknown spot, then we need to know both the weight and the mass of an object at that spot. So we want to find the acceleration due to gravity near planet X if a 125 kilogram object, so 125 kilogram object, has a weight in Fg equal to 579 newtons. So we have G equals Fg over mass. So that's 579 newtons divided by 125 kilograms. And that gives us 4.63 meters per second squared. And that will also act down. But again, that isn't really necessary in the calculation. Okay, and there's just your worksheet to do, which I don't have that quite made up yet, so the Mrs. Walker will let you know which questions that you need to do to practice for tomorrow. And we'll talk about Newton's third law on Wednesday.